Okay, thank you for introduction. Let me start. I think it would be really fine right now. Yeah, thank you so much. Yeah, as you mentioned, the title is using blockchain to achieve decentralized privacy in IoT healthcare. And yeah, thankful. I want to say thank you to my co-authors, Mohammad Beheshti-Atashgah and Mohammad Reza Aref, who was my advisor in Master Studies. And yeah, I'm a PhD candidate at Illinois Institute of Technology right now. So let me talk more about my paper. Okay. Just know what the problem is there. Okay, yeah, good. The hypothesis behind of this, paper, the main idea is about designing a privacy-preserving and secure blockchain-based access control for sensitive healthcare data. As you know, the Internet of Things implies that any device can be connected to the other devices and the Internet at any time and anywhere. So one of the main applications of the IoT is ehealth or electronic healthcare, where different types of wearable sensors measure patients' vital signs like heart rate, body temperature, blood glucose, blood pressure, and etc. These sensors automatically collect data about the users and transfer them to a central storage or cloud for further processing by doctors, nurses, and medical staff. The patient's data are privacy sensitive and usually stored on a server or processed remotely. This raises the patient's concern regarding the confidentiality and the privacy of their data. So the traditional privacy preserving methods that are based on the summarizing or creating noisy data are not efficient in healthcare applications where the user's original data are required for medical treatments. To address this issue, we tried to propose new privacy preserving scheme based on the blockchain technology. Let me talk a little bit about the blockchain. Blockchain is a multiple time-stamp ledger of blocks that is used for sharing and storing data in a distributed manner by a peer-to-peer network. And the blocks in blockchain are shared across all participating nodes, which eliminates the need for a central authority. And then there is no any need for a third party to for creating a trust or something like this. And you know this technology these days, this is a basic technology behind of the cryptocurrencies and something like that. But in this work, we don't want to take care about the financial application of the blockchain. We want to use this to, for example, apply it in another application like ehealth and IoT. But there are some, problems to, do this work. So let me introduce these matters that we need to consider in this work. The scalability is the first one. The IoT devices are resource constrained, so it's hard for them to solve the operation computationally for consensus algorithm, for adding a new block on the blockchain layer, especially, for example, in a proof of work, which is the most common one in the consensus algorithm. So we can eliminate the concept of the proof of work for consensus in the blockchain network and use another alternative method called practical design fault tolerance, which is a consensus method based on voting. And the PBFT involves multiple rounds of the voting by all nodes of the network. So let's go through the data storage, which is another matter that we need to consider. So it's not practical and suitable for to store IoT big data on the blockchain ledger. Because of this, we do not store our IoT healthcare data on the blockchain directly, but only we store the pointers to the data, the hash of the encrypt data on the blockchain instead. To do some lightning to the storage space of the blockchain. The data, I mean, the encrypted data are stored on another, off-chain, we call that off-chain storage, another storage, which is off-chain storage, it's not on the blockchain. I will talk about it later. So regarding to the security of data, I can say the patient's healthcare data are highly sensitive. And to satisfy the security of data, we use encryption, the method of the cryptography, symmetric key encryption based on the AES, which is the standard scheme for symmetric key encryption to achieve the security of data. At first, the data is encrypted by symmetric key of encryption and then send it to the blockchain network. So even in off-chain storage and blockchain storage, the information will be stored in the form of the encrypted data or hash of the encrypted data. I can say the hash of the encrypted data will store on the blockchain, which is really light, and the encrypted data itself will be stored on a off-chain storage. And another important thing that we want to outline in this paper is the patient's privacy. The main concern that is addressed in this paper is the patient privacy preserving, because the patient's healthcare data are highly privacy sensitive. Maybe you know that there are a lot of information in the web that you can access that why they are so sensitive. The healthcare data will be really important for us because they are storing in a dark web, for bad guy and something like this. So our proposed platform satisfies the following items for privacy. First, ownership. In our platform, patients are only owner of their healthcare data, and only they can control that data. As such, the platform recognizes the medical staff as service provider with a granted permission set, and the patients as a healthcare data owner. It will be really fine-grained access control. Each patient can grant a set of the permissions to any desired member of the medical staff for accessing the patient's healthcare data. Also, the patients can alter or revoke the set of the granted access permission whenever they want. These permissions are securely stored on a blockchain ledger as access control policies, where only the patients can change it or revoke them. And also, it will bring us data transparency and auditability. That means the patients have a complete and accurate transparency over the collected healthcare data, and they can know how medical staff can access to the healthcare data. So I can say our proposed system model consists of the following main modules. First, wearable IoT devices and patient's smartphone, medical staff, blockchain, and off-chain storage. So let's see how they are working together. In this figure, you can see what is going on. Let me tell you how this process is going. First, wearable IoT devices. The wearable IoT devices will collect all healthcare data from the patient's body, such as blood pressure, blood temperature, and heart rate. These devices have a limitation in resources such as low energy, low processing power, and little storage space. By considering these limitations, wearable IoT devices send the collected healthcare data to the patient's smartphone using short-range communication such as Bluetooth or Zigbee. And about the patient's smartphone, I can say the smartphones are more powerful than IoT devices because the smartphone has more strong space, more battery life, and higher processing power, operating system, and so on. So smartphone can do more complicated work, such as computational and cryptographic operations. Also, smartphone can transmit data via long-range communication, such as a cellular network that can be play a role of the gateway and allow patients to interact with the blockchain network. Also, medical staff, including physicians and nurses, should receive patients' healthcare data and, after analyzing it, obtain information about the patient's health status, and then they provide the appropriate treatments or alert or alarm to the patients. And the blockchain, I can say, in our work, we use blockchain to store access policies and eliminate the need for a third party that to preserve the network against preserve network against denial of service attack and single point of failure. It also ensures that the availability and integrity of the data for patients. The data is not stored on the blockchain, as I said before, but only the pointers to the data, which is the hash of the encrypted message and data, will be stored on a blockchain to lightening the storage space of the blockchain. And the off-chain storage, we can say we store the patient's encrypted data on an off-chain storage, and we can, consider for the implementation of the off-chain storage to use the interplanetary file system, which is IPFS. That is a peer-to-peer distributed file system that seeks to connect all communicating devices with a same system of files. If we consider IPFS, we can say it has no single point of failure because it's distributed and do not need to trust each other. So not using the central server is the reason for the advantage of the IPFS over the conventional cloud storage. Also, it's possible to use the conventional cloud storage, but I mean, if we use the distributed off-chain storage like IPFS, so we can say the whole of this model and this system would be distributed and decentralized, which is really powerful and good for us. And it will remove the need for a third authority. So in this slide, we can see the protocols that we have in the paper. I don't want to get in more depth in this algorithm, but I just want to give you an overview of how they are working and what is going on there. So we have 4 protocols here, and you can say this method, this model contains all of the IoT application and the blockchain and the cryptography, which is a main purpose of this international conference. So let me give you a quick idea how they are interacting. From the protocol 1 in the left-hand ball, I can say it's related to the joining to the blockchain. That means they are running the cryptographic challenge to produce the keys, for a signature and the symmetric encryption. So let's think about the protocol 2, which is in the right hand in the bottom of the page. It's related to the access control transaction. By sending it a T-access or access control transaction on the blockchain network that contains a policy between patients and medical staff, the patients give a desired permission, whatever they want, to the medical staff related to the types and which kind of data. The patients can send another access control transaction and change the previous permission, the granted permission set, which granted to the medical staff before. Also, in protocol 4, talking about data storage and retrieval, which is a T-data or data transaction. Data transaction is used to store patients' encrypted healthcare data on the off-chain storage, and which is the IPFS, or access to stored data and retrieve it. The patient for storing and retrieve the data, and the medical staff only for retrieving the data that patients stored them before, can send the T data or data transaction to the blockchain network. If the data transaction, by patients or medical staff, is sent to the network, the node in the blockchain first check the with the protocol tree whether the who sent this request have an access permission or not. After checking the access permission by protocol tree and the transaction sender's approval, he or she can store or retrieve a patient's encrypted healthcare data with the protocol 4. Yeah, I just want to give you an overview. If you are more interested about this, protocol to see what is going on, you can. I'm referring you to the paper to see in detail and study about the cryptography methods in this paper. And yeah, let me go to the security requirements evaluation. For security designing in any model, there are some main security requirements that need to be addressed: confidentiality, integrity, and availability, and somehow authorization. Confidentiality makes sure that the system message should be read by only authorized user who can access the system. The data integrity is responsible for making sure that no one without permission can change the stored data. And the availability of the data means that when user needs to the data, it's available for them. I can say that our system achieved confidentiality by using the symmetric encryption, especially I can say using the AES. And also hashing of the data in the blocks of the blockchain is employed to achieve the integrity, and the availability is achieved by limiting it in acceptable transaction in the network, and using digital signature based on elliptic curve cryptography ensures that we can achieve the authorization. Also, we have made a comparison between our proposed model and the other existing system, and we can see that we are using the blockchain. Some of them do not using the Yang and Zhang do not use the blockchain, but there are several works that they are using the blockchain in this area. But I think our model is more efficient because we did a kind of conversion to show that it's using the another methods for consensus algorithm in the blockchain, which is more efficient. And also we use the IPFS as a off-chain storage, which make it totally distributed system, which is really compatible with these days application. And there is no any single point of failure. There is no any third party even for off-chain storage. So I think it's more efficient. And before conclusion, let me tell you something more. We are working on for example, smart contract and decentralized application, or DApps, which is based on blockchain. And as maybe you know that what are the DApps? DApps are the program which the front end is like the other web applications, but the backends will be the smart contract, which is the backends will be based on the blockchain instead of the traditional server. And yeah, it could be a really good idea to pursue this way to make it compatible with the DApps and smart contract, and make it possible that you introduce a decentralized application for this system. And we are going to design it and implement it, this to put it in a everybody access. So in the conclusion, we can say in this paper, we proposed a novel platform based on the Internet of Things and the blockchain technology motivated by the privacy and the security challenges of patients' healthcare data in e-health application of the IoT. And also our proposed platform enables patients to have full ownership and full control over their sensitive healthcare data collected by their IoT wearable devices. And this ownership and complete control over patients' data are satisfied by storing access control policies in a blockchain ledger by, patient to specify who from medical staff can access to what kind of type of the data. And in this platform, we use blockchain storage to lightening the, off-chain storage to lightening the blockchain storage. And thank you so much for your consideration and attention. If you have any question, I'm here to answer. And this is our references for this work. Thank you so much.